Okay, so this is going to be our week 8 tutorial, and we're going to go step by step here and focus on how to reduce a radical. I guess in a so-called perfect world, all radicals would look something like this: the square root of 16, which we know happens to be 4. Why? Because 4 times 4 is 16. Or if you have something like, let's say, the square root of 100. Well, since 10 times 10 is 100, then the square root of 100 would be 10. But in mathematics, especially the higher up you go in mathematics, the less you see things that are quite this simple. Instead, we're going to see something, like maybe this. Let's say we have the square root of 32. Well, 32 is not a perfect square, but if you think about the square numbers, you should realize that 16, which is a perfect square, goes into 32 2 times, because 16 times 2 is 32. Now, this is just the square root of 16 times the square root of 2. In other words, we can separate this out as follows. And then we can go a step further and say, well, the square root of 16 is 4, and there's no square that goes into 2. So the final answer for that would be 4 on the square root of 2. Same thing with, let's say, if you were to have something like the square root of 700. Well, we know that 700, there's no number times itself that is going to give us 700, but we do know that 100 times 7 is 700. And why am I using 100? Because 100 is it's a square number. And I can write the square root of 100 times 7 as the square root of 100 multiplied by the square root of 7. And if I want to keep going here, which I should, the square root of 100 is 10. And the final answer would be 10 on the square root of 7. Okay, so those are just some warm-up activities. Let's go ahead and get to the problem at hand. If you look at the square root of 240, now, I don't know about you, but I immediately think, well, 4 is a square, and 4 will go into 240. But the problem with using 4 is it's not the biggest square. We can use it. It's almost like reducing a fraction. If you do not choose the biggest number that goes into the numerator and in the denominator, then you end up having to factor it, or simplify it again. For example, if we were to use 4, if I were to say, well, 240 is 4 times 60, and then I could say that the square root of 4 is 2, so that would leave me with 2 on the square root of 60. But 60 happens to also be 4 times 15. So I found another square hiding in there. And again, the square root of 4 is 2, and then 2 times this 2 would give me 4 on the square root of 16. So if you don't choose the biggest square to simplify these, that means you're probably going to end up having to do the work more than once. In fact, that's exactly what will happen. So our goal is to try to figure out the biggest square that goes into 240. And what are the squares? Well, 1 is a square, 2 squared is 4, which does work, but you have to simplify it again. And then we would look at, say, 9 and 16. And I would probably just take a calculator and check each of these. And we will eventually come to the realization that, hey, 16 times 15 is 240, which means you can take the square root of 16 times 15. You can break it apart like this. And that will give you the square root of 16 is 4. And the answer is 4 on the square root of 15. And the slowest path is the one that I did at the very beginning. We started off using 4 times 60 for our 240. Not exactly a tragedy, but it does mean that we have to do an extra step, right? We just have to keep simplifying this down. And again, it's much like if you have something like 25 over 100. instead of using 25, right, as the greatest common factor, let's say you happen to use 5. Well, then 5 goes into 25 5 times, and then 5 goes into 120 times. Well, since you didn't use the biggest number, then you're simply going to have to reduce it again. So 5 would go into 5 one time, and 5 would go into 5 would go into 24 times. Where ideally, you would have noticed right away that 25 should have been the number that you used, but using the 5 did eventually get you there. So the moral of the story is, it's the same thing as simplifying a fraction. If you're simplifying a radical, always try to isolate the largest square and then go from there.